Hi all, welcome to this video where we'll continue with the LL Bean example that I introduced you to in the previous video. Now, there are a few important metrics that are not given here. So let me quickly show them to you. So a few things to keep in mind is that each parka that LL Bean makes costs LL Bean $45 to make the parka, and they will be sold at a catalog price of $100. So we'll be spending $45 to make them, and we'll sell them for $100. Now, any unsold parkas at the end of the season will be sold for $50 at the outlet store, which means that we will basically not make much of a profit. But in fact, because we held the parkas in inventory and we have to transport them to the outlet store and all of that, it costs us an extra $10. So we can only sell it for $50 at the end of the season, but it also costs us an extra $10 to transport it and hold it in inventory and so on. So basically, the salvage value. So if you're not able to sell it during the regular season, the amount of money that you make from the parka is $40, which is less than the cost of the item. And that is how it usually turns out. In a lot of the seasonal inventory models, the salvage value is less than the cost at which you cost of making the item or buying the item, however you look at it, right? So before we get to all of that, let's look at this demand itself, and let's talk about the demand a little bit. So if this is the case, what is the average value of demand? So usually, if you wanted to find the average value of demand like this, demand can be anywhere between 14 and 1700. You just you do 1400 plus 1700 divided by 2, and that will give you 1050. That would be a decent value for average value of demand, but you cannot do that because the probability of demand of each of these values is different. The probability that it's 400 is 1%, probability that is 500 is twice that. So because the probabilities are different, you cannot directly just add the numbers and divide by 2. So you cannot just add them all up and then divide by the number of numbers to find the average. Instead, you'll have to find a weighted average, right? So what is the average value? So to find the average value, you say the demand is 400 1% of time. So 400 times 1% plus 500 times 2% plus 600 times 4%, 700 times 8%, and so on. And then we add them all up, we will find that the average demand is around 1026. That's approximately the average value, right? So if the average value is around 1026, can we calculate the profit of the expected profit if we order 1000 parkas? What will our profit be? And then what we'll see is we'll see what happens if we order 1100 parkas and we order 1200 parkas, and we'll look at all of these different scenarios. What I'll do is I'll do all of this in an Excel file so we can see how the calculations are done. So, but the idea is, so the bottom line here is for us to figure out what is the best order quantity. How many parkas should LL Bean make for this season, given this demand distribution and given this cost structure? How much should LL Bean make for this season? That's what you want to try to figure out. So before we actually look at the methodology of doing that, let's do some exploration and look at this demand and talk a little bit about this demand distribution and what we can get from that. So I've written down the values here. So I can find the expected demand. So expected demand is just another way of saying average demand. So expected demand is 400 times 1%, 500 times 2%. You're multiplying the corresponding values and adding them up. So the simplest way to do that is to use the sum product function. So you can say sum product of the demand values and the probability values will give us the average demand, which is 1026, right? So that's what we found it. So on an average, that is our demand. Now, what if I want to find out what happens? So what is my expected profit? So I want to find expected profit if I order 1000 items, right? If I order 1000 items, what is my expected profit, right? So I define my expected profit if I order 1000 items. So we look at 1000. The reason I'm starting at 1000 is because demand turned out to be 1026. So if we round it down, it comes to 1000. I mean, we could potentially round it up, but because it's less than half, we're rounding it down. So what happens if I order 1000, close to the average value? So Here are the cost values. So we are the sales price will represent by S. Sales price will be S, and sorry, sales price will be P. I'm sorry, not S. Sales price will be P, and this is $50. The cost of making the item will be C. Actually, we end up using lower cases for this. So let me. Cost is C. So, sorry, sales price is $100. Cost is $45. Right? Cost is $45. Yes. And salvage value. Salvage value is S, and that is $40. Right? So you can only recover $40 at the end of the season, which means that you still have to make it. So you'll make it for $45, you'll sell it for $40, and so you'll essentially make a loss of $5 if you're unable to sell it during the season. So that is the crucial point here. So if I order 1,000 items, right, what happens? So if I order 1,000 items and demand turns out to be 400, then I will be able to sell 400 items and 600 items will have to be salvaged. Now, if I order 1,000 items and demand is 1,000, then I can sell everything. But if I order 1,000 items and demand is 1,400, then what happens? Well, then I can only sell 1,000 items. That's it. The remaining 400 units of demand is just lost. You can't do anything about it, right? And so that is something to keep in mind. So what we'll do is, to find the expected profit, what we'll do is we'll calculate the profit for each of these scenarios, and then just calculate the expected profit just like we calculated expected demand. So this scenario happens with a probability of 1%, this scenario with a probability of 2%, and so on. So we'll just calculate the expected profit that way, right? So let's calculate this expected profit, right? So what happens if we order 1,000 items and demand is 400? So if we order 1,000 items and demand is 400, we can only sell 400 items, right? And what can we sell this 400 items for? We can sell this 400 items. Sorry, how much profit do we make from these 400 items? For these 400 items, the profit will be 100 minus 45. Why 100 minus 45? Because we can sell the item for $100 and it costs us $45. So we will make $55 of profit for selling the items. So selling these 400 items. Now the remaining 600 items, which will be 1,000 minus 400. So for the remaining 600 items, what we're going to do is we are only going to be able to make a profit of, so we are going to lose money, right? So we're going to sell it at $40 and it's going to cost us $45. So you're going to lose $5 on those 600 items, right? And that is the expected profit that you make when demand is 400. So again, so for 400 items will be sold at 55, we'll make a profit of $55 on these 400 items. We'll sell them for $100, it costs us $45, so we'll end up making $55 of profit for the first 400 items because demand is only 400. The remaining 600 items, which was 600 extra that we had, well, we'll have to salvage them. And when you salvage them, you basically lose $5. So you're going to sell it at $40, it's going to cost you $45. Either way, one way or the other, it's going to cost you $45. And there you go. So the expected profit will be 19,000, right? So similarly, I can do this. Oh, oops, sorry. Bad, I forgot to do dollar signs. Obviously, all of this will be under dollar signs because these three numbers don't change. So A2 should be okay. B2, no, this is again dollar signs. There you go. So all of these, so this is going to have, so these profit values and everything that you see here, these things are going to happen as long as demand is less than 1,000. So once demand hits 1,000, right? what happens here is you're going to make $55 of profit on all of these 1000 items. And because you're doing 1000 minus 1000, this scenario is not going to play out. So you make $55,000 of profit. That's the maximum amount of profit that you can make in this scenario. You stock 1000 items, you sell 1000 items, you're done. In the rest of the cases, it doesn't matter what demand is. You can only sell. You will make a profit of. Sorry, you can only sell 1000 items because you ordered 1000 items. It doesn't matter what demand is after 1000. You can only sell 1000 items, and you will sell that at the full $55 price, right? All of this is. And that's the profit that you expect to make. So in all of these cases, you'll only make a profit of 55,000 because even though demand is more than 1,000, you can only sell that. So again, expected profit is so scenario times the probability, scenario times probability. So again, I'm going to use some product. Right? So $49,900. So that's the expected profit. How did we come up with this? We say that there's a 1% chance that you'll make $19,000 in profit, 2% chance of 25,000, 4% chance of 31,000, blah, 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 all the way up to, there is all of these percentage chance from 1,000 onwards. If you just add these numbers, there is a 49% chance that you'll make $55,000 in profit, right? Because demand is 1,000 or more, and that's how much profit that you make. Now this is if you order 1,000 items. So as you can see, when you order 1,000 items, starting from 1,000 all the way down, the profit will remain the same because even though your demand is higher, you cannot satisfy that demand. You can only satisfy the demand up to the point that you've made. So what if we order 1,100 items, right? What if you order 1,100 items? So we can do something similar. So I'll go through this quickly. So you, for the first 400 items, you will do this at $55, right? 100 minus 45. Again, we're gonna make these absolute references, right? For the remaining 700 items. Why 700 now? Because we started 1,100. So we are ordering 1,100 items. For the remaining items, we will be losing $5 in profit, right? These again are. So you'll make 18,500. So profit is less. Now this will go on up to 1,100 because here you'll make 1,100 items. You order 1,100 items. Demand is 1,100. You'll be able to sell everything. You'll make $60,500 in profit. And then for the rest of these cases, you'll still make $60,500 in profit because you can only sell 1,100 items and you can sell them at the $55 profit level. Right? So when you do expected profit, it's the same thing. Some product of the potential profits and the corresponding probability values. That gives you a probability profit of 52,340. So if you order more, you see that the profit goes up. Now we'll do two more scenarios quickly. What happens if you order 1,200 items? Sorry, 1,300 items, and if you order 1,400 items. So these are the two scenarios we'll quickly go through. So again, I'm going to do this, right? So the first 400 items will be sold at $55. Oops, sorry. The remaining, so we're doing 1,300, right? The remaining 900 items will be sold at a loss of $5. This is going to happen all the way up to 1,300. Now starting here, you'll be selling only 1,300 items, and you'll do this at $55. There you go. Expected profit is some product of the potential profit values and the corresponding probability. So again, why are we doing this sum product? So you're saying that we make $17,500 of profit with a 1% chance. So 23,500 profit with a 2% chance, 29,500 with a 4% chance, and so on. So to multiply the probability with the corresponding values and just add them all up. There you go, 54,160. Finally, right? This time it's 1,400. $5 loss. There you go. So this will go all the way up to 1,400, and here we'll make 1,400 times corresponding probability values, right? There you go. Now you'll notice that profit, as you kept ordering more, profit went up to 54,160, but when you ordered 1,400, the profit went down to 54,140. And this is exactly what you will notice. You'll notice that as you keep ordering more and more, your profit values will increase, and the maximum will be at 1,300. Maximum will be at 1,300, and then it will go down again, right? So that's the optimal order quantity. So we'll talk about why this is the optimal order quantity and all of that. But there's one other thing that I want to talk about. This video is going on for a really long time, but there is one other thing that I want to talk about here, which is the fill rate. We'll talk about the fill rate, and I'll end this video here, right? You know what? We'll do the fill rate in the next video. So I'm going to end the video here. In the next video, we'll talk about fill rates and the optimality of the order quantity and so on, right? Now, one last thing I'll point out here is that the demand that we assumed here follows this sort of pattern, where it takes specific values with specific probabilities. This is called a discrete demand distribution. So I'm going to call it discrete demand distribution. So demand takes discrete values. It takes specific discrete values. So it's called a discrete demand distribution. Now we'll look at other ways, other types of demand distribution, and we'll do that in the subsequent videos. Right? Okay. Take care.